Hello friends, today in this video we'll be understanding the Wiggly sequence problem from the lead code. The difficulty level marked for this question is medium. Now let's first understand the question and the problem constraints that are given to you. So now let's first understand what is a Wiggly sequence. So Wiggly sequence is a sequence where the difference between the successive numbers is always alternating. That means if the difference between the first two pairs is positive, like greater than 0, then the difference between the next consecutive pairs would be negative, that is minus 0. So if you see in this example, the difference between these two pair is positive, that is plus 6, and if you see the difference between these two pairs, it is minus 3, and then again if you go towards this place, it is again positive plus 5, and so on. So this is a perfect example of a Wiggly sequence array. And if you see this one, you don't find the sequence alternating. It's always either increasing or decreasing too much. So it's not a perfect example for a Wiggly sequence. Now, in the problem statement, they are asking us to find out the maximum length of the Wiggly sequence. You can remove many elements, any number of elements from the given array, and try to find or figure out if there exists a sequence. If there does not exist a sequence, that also you need to figure out. So let's understand that with an example, what should be the output in case if uh, the complete array is not totally following the Wiggly sequence. That we'll understand with an example. But let's first understand the constraints before we start understanding the example. So over here they are mentioning that number of elements that would be given to you in the array would vary from one element to 1,000 element, and any number in that array would be ranging from 0 to 1,000. That means you would not have negative numbers or any number greater than 1,000. Now let's understand few examples and then come up with an approach to the solution, and we'll probably try to figure out big O n time complexity. So now I'll also discuss few edge cases with you guys, because that is clearly also mentioned in the question, because it's mentioning that there, if a sequence is having only one element, then the sequence or with two non or a sequence with two non-equal element is also a Wiggly sequence. So we will have to figure out this edge case also. So let's take an example of this edge case and understand this. So let's say I have an integer array with only one element. Now you see the difference that is possible is nothing. So you cannot find difference because there does not exist any other element. So this is a perfect example, and the maximum length of the Wiggly subsequence would be 1. If we have 1 comma 2, then so this is having one pair, and that one pair also has a difference of 1. That is why this is also a Wiggly sequence, and the maximum subsequence length is 2. But what happens if these are both same, 1 comma 1? Then the difference is neither less than 0 or greater than 0. It is exactly 0. So that's why it is not considered completely as a Wiggly sequence. So we'll just mark only one element. We'll only consider one element as in the Wiggly sequence, because that follows the first case. So the maximum subsequence length would be 1. So these are few edge cases that were given to you in the question, and you'll have to take care of these cases as well in your code. Now let's take with a valid example where we have a valid length of array, and we keep removing few elements if in case needed to make that complete array as a Wiggly array. Now let's take that example. Now let's see this example and try to figure out if this complete array that is given to you is following the Wiggly sequence properties or not. If this is not following, then we'll try to figure out what elements we have to remove from this array to make the resultant array to follow the Wiggly sequence strictly. Now let's try and understand the difference, find the difference of the consecutive pairs, and see if uh, this is following the Wiggly sequence or not. So over here, if you see, this is a difference the of positive 16, then the difference becomes negative 12. Then again, if you see, compare these two elements, the difference is positive 5. But if you see over here, the difference is again positive. That means it has broken the Wiggly sequence subsequence property now, because this element now should have been a negative value. Now, to make this negative value, we don't have anything right now, but what we can do is we can strictly skip 13 from our element array. So if we skip 13, so we don't have to find this difference, and we will go ahead finding difference for the next element with 10. So the next element with 10 pair would be again 15, and the difference is again plus 5. So this is again not following the Wiggly sequence. So let's remove this 15 as well from my array, and let's see if the next consecutive pair with 10, which forms with 10, does it follow the Wiggly sequence or not. So if I go ahead and I subtract 10 with 10, this also does not seems to follow, because over here the difference is 0. So I will also try to remove 10 from my subarray. So I have till now removed 3 elements. When I am on 10, I have counted till 10. So now let's go ahead and see if the consecutive element after this value, does it allow us to follow the Wiggly sequence. So if we consider this element, so the difference is negative, yes. So now, so if my resultant array is somewhat like 1, 17, 5, 10, then comma 5. Now let's leave 16 and 8 as it is, because we have not done anything with them. And now let's see. So over here the difference is 16, over here the difference is minus 12, over here the difference is again positive, over here the difference is negative, over here the difference is again positive 11, and if you see over here it is minus 8. So this is my final Wiggly sequence, which is strictly following the complete property. So practically what I have done is I have removed 3 elements from my exact input array, and I've got the subsequence. So what is the length of this subsequence? So the length over here is 7. That means from this array we can form a Wiggly array of length 7. That's the maximum length that is possible for us. Now, what algorithm do you think is applicable over here? So understanding this example, there is a particular algorithm that we just followed, and I would just want you guys to take a pause for a minute and try to figure out what's the condition and how the algorithm has worked, and try to figure out that yourself. Now let's take another example where we have few elements that are same. So let's take an example where, let's say, we have 3 comma 3 comma 3 comma 2 comma 5. So this is, let's say, my array that was given to me. Now let's try to figure out what is the maximum length of Wiggly subsequence over here. Now if I do a difference between these two elements, that is 0. That means this is not the subsequence that I would want to have in my Wiggly subsequence. If I do the difference over here, again 0. If I do the subsequence difference over here, this is -1. So that means my Wiggly subsequence starts from this element. Now I will go ahead with after 3. So after 3, if you see, 3 and 2 forms a negative difference. So then 2 and 5 should find a positive difference. So which you see is a positive difference. So we'll practically be removing these two elements, because the resultant difference due to these two elements was becoming 0, and that would not have helped in forming the Wiggly sequence. So I've removed these two array, and my resultant array is again 3 comma 2 comma 5. So the length of maximum subsequence that follows the Wiggly properties is 3. So this is the second example. Now if you try to figure out the algorithm, you will feel that if the difference, if the difference of my current pair is less than 0, then my difference of the previous pair should be positive. Or if my difference of my current pair that I'm comparing is positive, then the last one should be negative. If this is positive, if this is negative, then the last pair should be positive. So this is how it should be. And if that does not follow this property, then I'll not increment my counter. That's a very basic property that we can uh, right now figure out. So let's write a basic algorithm, and then let's take that up with one more example, and let's see if that helps us in finding the maximum length of Wiggly subsequence or not. Now let's understand the algorithm that we just decoded in last two examples. So over here I have written in the first step, if the array length is equal to 1, then definitely we'll return 1, because that was the edge case that we had, and we had discussed that. Now if the array length is greater than 1, so that means we have at least two elements in the array. So we'll find the difference of the first two elements, and if that is not equal to 0, that means both the elements are distinct, then we'll set the count to be 2. So now we know that at least these two elements are distinct, so at least my minimum length of my Wiggly subsequence would be 2, because these two elements are non-equal. If they're equal, then I would set the count as 1, because we'll discard the first element and remove it, and we'll just have the second element as my Wiggly sequence, and we'll keep that up. Now in the third step, if the array length is now greater than 2, then this step would come into picture, because we start iterating from I equal to 2 to n minus 1, both inclusive. That means my array, my iteration would start from I equal to 2 and would end up to n minus 1, both inclusive. And I'll try to find out the current difference. This is my current difference, if you see. So current difference is array element, ith element, and its previous element, the difference between these two. So if my current difference is greater than 0 and last difference was equal to 0, or less than 0, or let's say my current difference is less than 0 and my last difference is greater than equal to 0, so this clearly states that there is an alternate between these three elements. Now why three elements? Because two elements we are considering in the current difference, and two elements were considered in the last difference. So these three elements are in the Wiggly sequence, so we could increase the count variable to +1, because we have just arrived one more position, and that helps in following the Wiggly subsequence. And we'll store the last difference in our current difference variable in my last difference variable, and keep running this loop. And by the end of the loop, we'll have the count variable having the maximum length of Wiggly subsequence that is possible. Now let's try to understand this algorithm with an example, and let's see if this algorithm needs some changes, or will it work in all scenarios or not. Now let's understand this example with our algorithm, in line with our algorithm, and see if this algorithm stands true for this example or not. So in my example, I have these elements where I have few repeating elements as well, if you see, and let's see, let's try and decode. So over here, if I see the length of the array is not equal to 1, that means my first step of checking is done. So I don't return anything. Now my array length is greater than 0, that means I'll find the difference between the first two numbers. So first two numbers, and I'll store that in my last difference. So first two number is 7 and 4, so difference between these two is definitely -3. So this is my last difference that have been stored. Now I go and this is not equal to 0, that's why my count variable, I'll also have the count variable. Let's have the count variable over here. So that means my count variable over here is 2. Now let's start with I equal to 2. So I equal to 2, that means this one. this element. So I equal to 2 and I equal to 1. What is the difference between these two? So the difference between these two pair is 2. So this is sorry, the current difference becomes 2. Now if I match this with the condition, the current difference is greater than 0 and last difference is less than 0. That means I would increment my count variable. So now my count variable becomes 3 and my last difference becomes 2. Now if I go to I equal to 3, so I equal to 3, that is this variable, so this one, so not this one. I'll remove this. So the difference between these two is equal to 0. So my current difference is equal to 0 and last difference is 2. So if you go ahead and see, so this does not match to any condition over here. So current difference is greater than 0 or current difference is less than 0. I don't have an equal to condition. So nothing would happen and my last difference would be as it is 2 and my count will remain 3, sorry. Now I go to I is equal to 4. For I is equal to 4, that means I am on this element, that is I4. So 7. So the difference between 7 and 6, what it is positive. That means plus 1. So my current difference is plus 1. Now if I check this condition, so current difference is greater than 0. Yes, the last difference should be less than or equal to 0, which does not match. If I go ahead and see this, my current difference should be less than 0. This is also not matching. That means I'm not having this as true. So these two variables will remain same. Now if I go to I is equal to 5, that means to the fifth index, if I see this, so the difference between these two consecutive elements is minus 2. So minus 2. So my current difference is less than minus 2 and last difference is greater than or equal to 2. That means my count will increase to 4 and my last difference would become minus 2 now. I go to I is equal to 6. I is equal to 6. So the difference over here is again minus 2. So current difference is minus 2, which is not following this condition. So we'll do nothing over here, no changes. So practically we have till now we have removed 1, 6 and this 3 we have removed and so on. So we have till now removed 3 elements from here. So yes, now let's go to next index where I is equal to 7. So that is this one. So if I see, this is 4. So my current difference is from the last two elements is, so 3 and 4. The difference is always plus 1. So the difference is 1 and the last difference was my negative. So that means this would follow this condition. I would increment my counter to 5. Last difference would become 1. I is equal to 8. I is equal to 8 is over here. The difference is positive. This and the difference over here is not alternating. That's why we have no changes over here. We remove this, we move to next element, that is 5. I is equal to 9. The difference between these two elements is negative, minus 1. This satisfies as condition. That's why the last difference would be this and the count variable would be increased. Now I is equal to 10. I is equal to 10. So difference between these two is current difference is 0 and this is not following any of these conditions, so I'll leave everything as it is. Now let's move to I is equal to 11. 11. So the difference between these two is minus 2, sorry, positive 2. Current difference is positive, the last difference is negative. It follows our condition. That's why the last difference becomes 2, the length becomes, the count becomes 7. Now I go to I is equal to 12. So I is equal to 12 is practically the last element of our original array. So over here the difference is minus 1 and so this last difference becomes minus 1, the count becomes 8. So my final answer is 8. Now if you see this with a normal case as well, if I go ahead with removing the elements that should be removed for wiggly sequence, the array would become 7, 4, uh, then again 7, because this is decreasing, then increasing, then decreasing 5, then increase, this is decreasing, we'll remove till we get an increasing term. This is 6, then we go to 5, then we go to 7, and then we go to 6. So this has an length of 8. So if you see 3 elements and 2 elements, that is 8. So this is my final count. So that means our algorithm stands true for this example as well. Now this algorithm has a time complexity of big O n. Now why time complexity as big O n? Because we are just iterating on the complete array once. So we are starting from index 2 to index n minus 1, that is in step 3. So that is one iteration from index 2, and one we are doing over here. So practically it is iterating for all the elements over one time. So that means my time complexity becomes big O of n, and space complexity becomes O of 1, because we are not creating any new array or anything. So we are not practically having any new space that has been created. So the algorithm is this that we just discussed, and let's see this algorithm in place in a code. Now the code that I have written is in Golang. You can go ahead and write the code in any language of your choice, whether Python, .NET, C#, or C++, C, Java, any language that you want to write it in. Just try to follow this algorithm, and it should be done in your language. Let's see the code in Golang. Now this is the code that I've written in Golang. So if you see and understand, so this is my step 1, where I am comparing the length of the array with 1. So if the length of the array, that is n, so n over here is the length of the array. So if the length is equal to 1, I would return 1 definitely. Now I find the last difference with n with the array's first element and 0th element, and if that is not equal to 0, that means my count is 2. So this is practically step 2, where we have just found the count variable. Otherwise my count was actually initialized to 1. So if this would not have happened, my count would have remained 1 over here. Now I start my I with 2 to n less than n. So that means that it would only run till n minus 1 element. I find the current difference by nums I and num I minus 1, and then have this condition where I say if the current is greater than 0, the last should be less than or equal to 0, or if current is less than 0, the last should be greater than or equal to 0. If this is satisfying, then I'll increase my count variable to 1, and I'll update my last difference to my current difference, and in the end I return the count. So this is my step 3, and my time complexity becomes big O of n, and space complexity, if you see, becomes big O of 1. So this is the final code which you can write in any language of your choice. Now if you see this and you follow this. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from LeetCode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.